Hello and welcome to this Mile High Video 2020 presentation, an overview of the Reliable Internet Stream Transport, RIST. My name is Ciro Noronha and I'll be taking you on this discovery journey on this protocol. I am currently the EVP of Engineering at Cobalt Digital, and I'm also a member of the RIST activity group, which is an activity in the Video Services Forum. I'm also president of the RIST Forum for 2020. So what's the problem we're trying to solve? I want to use the internet as a cost-effective means of transporting high-quality, broadcast-grade video. But, and there's many buts on that, delivery of the internet is not guaranteed, so the video may glitch. It's packet loss. I need to be able to use whatever link I have or combination of links to transport my content. So yeah, there's stuff out there, but there's stuff with high latency. If I'm doing live, I want low latency. I need my content to be protected so it doesn't get stolen. So it's flowing through the internet. If it's valuable, someone's going to want it. So that can't happen. Bad people should not be able to hijack my link. So if I'm a reporter sending something, people should not be able to hijack that. And also, my IT people are very busy, and this must be easy and straightforward to set up. Okay, you can say, okay, I have seen people stuff like that in the market, and there's other solutions like that. So why is RIST different? Now, RIST was designed as a joint effort between many of the leading companies that do this for a living. And that was done in the context of the Video Services Forum. Essentially, the broadcasters came to the Video Services Forum and said, clean the house. Many people have this, but they don't interoperate. So come up with something that's common to everybody. So all these companies contributed people with hundreds of man years combined of experience looked at that, got together, and freely collaborated. So that created something that's a protocol that's best of class everywhere. So you as a customer are not locked to a single vendor. You can choose the best equipment for your application, and you can be sure that it interoperates. And you don't need to compromise quality because the RIST forum, the RIST group chose the best solution for each point. Let's look at what's available in RIST. The first thing that came out was called RIST Simple Profile that came out in 2018. And RIST Simple Profile has to do with getting the content there. Includes interoperable ARQ, retransmission throttling, link bonding, basically whatever you need to do to reliably get the stuff out there with low latency. Then in 2020, earlier this year, the protection part was released. So authentication, tunneling, making sure that the content is secured and you know who you're talking to. And is it done? No. There's RIST Advanced Profile. That's what the RIST Activity Group is working on. And that includes tunnel level enhancements like ARQ at the tunnel level, receiver synchronization, adaptive bitrate, and all kinds of stuff. That's not available. That's what we're working on right now. So, what's in RIST Simple Profile? Let's start our journey here. RIST Simple Profile starts with RTP, the real-time protocol. The good old, well-loved RTP is the base protocol. So you have basic compatibility. Something that's 20 years old can actually see a RIST stream. Now, on top of that, we add ARQ, packet loss recovery, using NAC-based ARQ. That means if you lose a packet, you ask for it and a retransmission is sent. And you don't acknowledge stuff that's correctly received. It's also called selective retransmission. The smart ones will also do retransmission bandwidth throttling so you don't overload the link. So features of that. It's bandwidth efficient, so you only retransmit what you need, and you have a tunable trade-off between latency and protection. So you do that by controlling the number of times you can request a lost packet. So you have a knob there. If you want to bias it towards lower latency with less protection, you go that way. If you want more protection at the expense of higher latency, you also can go that way. Very nice. It has multi-link support. We can use multiple links in parallel, and also IP multicast support, which we get basically for free with RTP. Now, since this is a tech presentation, let's look at the tech details. The stream is sent using standard RTP and requires two UDP ports, one for RTP and one for RTCP. RTP even port, RTCP the next odd port. The sender will transmit periodic RTCP messages to establish state in firewalls, and then receiver will send those back RTCP messages writing that state to keep the return channel operating, and then you have an echo message as well to measure latency. It's like a ping. If a packet is lost, RTCP messages, NAC messages are sent. We use RFC 4585 bitmask NAC messages for salt and pepper losses, and we have defined a custom risk range NAC for block losses. So you can optimize your NAC. Multi-link operation. So RISC supports multiple links in parallel for a given stream. What can you do with that? There's two things you can do with that. One is called bonding. You use the links in parallel to combine them as a higher bandwidth link. So just like the cellular bonding guys have been done for years, you can bond, split the stream between links. The other is what's called seamless switching, where you replicate over the links. You send copies of the stream, and then the receiver merges all the packets. So if a link goes down, nothing happens. It's seamless switching. And this is not new. You say, oh yeah, I've seen this before. It's SMPTE 2022-7. It's exactly SMPTE 2022-7 that was built into RISC. All right. Now we got the content there in a reliable manner. What else? Well, protection. So let's look at protection. Protection includes encryption, where you protect your high-value streams in flight over the internet, and authentication, where you make sure that the other side is what you think they are. The other thing we add to the main profile is tunneling, because we don't like that 2 UDP port thing, right? So if you have lots of streams, your IT people are going to hate you. So one port per stream, and you can also support non-risk traffic, so a technician can ride the connection back and manage the equipment. Other things in main profile, high bitrate latency conditions, and bandwidth optimization. I'll get into the details later. So let's look at tunneling and multiplexing. That's the first feature of RISC main profile. Purpose is to combine multiple flows plus arbitrary data into a single network flow using UDP. The advantage of that is that only one UDP port can be configured in the firewall, so IT is going to love you. Only one encryption session is needed if you're going that way, and you can start for either endpoint. It doesn't matter if you're the sender or the receiver, you can start it at either endpoint. And the tunnel is bidirectional, so one side starts it, but then you can flow both ways. Now, the same infrastructure can be optionally used for in-band controls. Such things like SNMP, web, or any other management traffic can ride the. So how do we do that? Again, the tech details, since it's a tech presentation. We chose RFC 8086, GRE over UDP for the tunneling, and we use two modes. One is called full datagram mode, where we put a complete layer 3 packet. This is how you support end-to-end transport of addresses and ports and any IP packets, your management, your in-band control. The overhead of that 32 bytes is about 2.4% of your typical 70S RTP packet. There is also a reduced overhead mode, which includes both only UDP and source destination ports, is not the full packet, and is only supports 3 streams. And what you get for that is only 8 bytes of overhead, which is 0.06% over your traditional 70S RTP packet. Here's an example of a tunnel where you have a bidirectional tunnel with data flowing both ways. The streams are sent both directions, and arbitrarily one side starts it, whatever is most convenient for you. This is a good example with lots of pipes. I like those drawings. Another thing included in the tunnel is an optional negotiation, which we use the JSON format, where you can exchange information. It's more for the user to see. You know who the vendor is, what the equipment is. So there's an example of how the JSON looks like. Content protection. It's encryption. You guys know what encryption is. So RISC decided to use something called DTLS, the Datagram Transport Layer Security, which provides both encryption and authentication. The advantages of that is this is the UDP version of the TLS technology already used in the internet. It's what you use to connect to your bank website. It's mature and well vetted. You don't want to invent encryption. You want something that people have tested and vetted. And you have the ability to select multiple ciphers. So we'll apply that at the tunnel. So what the ciphers are? So in order to ensure compatibility, we selected a number of subset of the cipher suites available for DTLS. Those ciphers include AES 128 and AES 256 with 2 types of authentication, also a no encryption for optional fallback. Why we have 2? Because in some parts of the world 256 is not legal, so you can't use that legally. But in some parts of the world, if you say 128, people laugh at you and say not secure enough. So there's no one size fits all here. It's a good compromise between encryption strength and ability to adhere to local legal requirements. Vendors can add to that list if they want. Authentication comes together with DTLS. So we have certificate-based authentication, which is same technology. You connect to a bank, the bank sends a certificate, and your browser says it's all good. Same technology. But you can authenticate both ways, server and client. The user is in full control. You can have a whitelist, a blacklist, use a private CA, use a public CA. It's up to you. If you don't like certificate-based authentication, RISC also defines password-based authentication using something called TLS SRP, Secure Remote Password. All right, I don't like this DTLS. I want something that works for multicast because this has got a negotiation. So RISC defines something called pre-shared key, PSK. The details of that you see flying over here is basically you share a passphrase with everyone that's supposed to be able to get that stream, and then from that passphrase you create an AES either 128 or 256 key, and this has all the goodies. It's a variable IV. You change it for per packet since CTI. You have to do that, and you can rotate keys as often as you want. And you can also have support for on-the-fly passphrase change, which supports a case where you have someone that was authorized, now you got to kick him out, you change the key, you don't tell them, and you can on-the-fly switch the key. Everybody who's got the new key automatically uses it, and that guy who you wanted to kick out is now out. So this is good for one-to-many and unidirectional scenarios, and satellite replacement is a good example of that. Bandwidth optimization, I promised that, right? And that's specific to MPEG transport streams. They have typically 5% of null packets. They have no data, but they are necessary to keep stream time. So new RISC main profile can reclaim the bandwidth for null packets using the following. You take them out, but you keep track where they were. You send flags on that, where they were, and you send a smaller packet. And then on the other side, the packets are reinserted. So you save that bandwidth. And that is supported by 13.818-1 section 241. And I have to say that because some people like to put stuff in the null packet, and that's not legal. High bitrate operation, you're talking about uncompressed video. Can you use RISC for that? Yes, and we are liaising with the 2110/1 people for that. But then you have a problem. 16-bit sequence number on RTP, that's not going to cut it. So that limits the NAC window to 64K packets, and at high bit rates, this is insufficient. Remember, the RTP was built a long time ago, right? So RISC main profile includes a header extension to bring the sequence number to 32 bits, which is more than enough for high bit rate operation. All right, here's a table which I'm not going to read for you, and I just want to point out that RISC uses the Lego approach. That's something that the AG chair likes to say. Rick Ackerman is the AG chair. We don't reinvent the wheel if we don't have to. We use our existing RFCs whenever it's possible. So here's the list. You're going to get the PDF, those slides. You can read that. It's just to show you what's the basis of RISC. Now, is there open source implementation of RISC? Yes. It's in GStreamer and UPipe. And if you want to put that in your own project, there's something called LibRISC, which you can get in video dev. You can download that and freely use that. It's available now on FF. It's going into FFmpeg, and it's available on VLC. There's also Wireshark plugins to decode RISC. You want to read stuff? Yes, it's out there. The documentation is out there. The source is out there. So the RISC specifications are freely available from the Video Services Forum website. VSF TR06-1 is RISC Simple Profile, and VSF TR06-2 is RISC Main Profile. You can go and get them right now for free. There's a web page for the RISC Activity Group. There is a web page for the RISC Forum. RISC Forum is the marketing organization that tries to educate the market about that. And if you want to know how well that works, I gave a paper last year at NABEITC. There is a performance evaluation. Remember when we had trade shows? That's when that happens. Not this year, though. If you want to watch stuff, there's this RISC promo video. It's like a marketing thing with nice music that you can watch. It's very fluffy. There's no technical information, but it was a good effort. So I put the link over here. If you want me to explain to you how ARQ actually works, there's an ARQ primer in YouTube as well. It's me talking at you again, but it's just 5 minutes. If you want to learn that, it's there. In every trade show, we had a RISC demo, a multi-company, multi-continent RISC demo, and there's a playlist of that, so you can go watch that. And that's that. My name is Ciro Noronha. You have my contact information there, and you can contact me if you want and if you have any questions for this. Thank you very much for your attention to